All right, 1.2, transforming with coordinates. First, predict where each transformation will land. Next, carry out the transformation. Okay, so I would really recommend, if you're doing this, well, you should be doing this, to use different colors because it's going to get a little bit cluttered with all these different transformations. So I'll try and do my best to make it clear and obvious. All right. So for number 1, it says rotate figure H clockwise using center 2, 0 by 90 degrees. So clockwise is this direction. So if I rotate this clockwise, it's going to end up in this quadrant 4 right here. Translate by the directed line segment 2, 0 to 3, negative 4. Okay. Well, if I'm going from 2, 0 to 3, negative 4, I'm shifting it down. So this shape is going to be like twisted on its side in the 4th quadrant and then brought down. So it's probably going to be like somewhere around here. So that's where I predict H is going to be. So that's good to know, because if you're doing the transformation, as you're doing it, you want to make sure that it's probably going to end up where you predict it's going to be. Or if it doesn't, think about why your prediction was wrong. All right, and really when they say directed line segment, just to make that abundantly clear, they're talking about a translation. So if I'm going from 2, 0 to 3, negative 4, that's a translation of +1 in the x direction and -4 in the y. So that would be T1, negative 4. All right, so because we're doing a rotation that's not centered at the origin, I can't use those rules that you guys had to memorize for that course we took for the break, or whatever you want to call it. So we will have to use a compass. All right, luckily though, this point here, I'm going to label these points because that's what a good math teacher would do. I'm going to call this, let's call it A, B, C, and D. All right, since A is on the center of rotation, it's not going to move at all, so I don't really have to worry about rotating that one. But I will rotate C, B, and D. All right, and maybe I'll notice a pattern and I won't really have to, do too much work with the compass. Okay. So I know that if I take that point C and I go right through my center of dilation at A, wherever I end up, that's going to be a rotation of 180 degrees. So if I want 90 degrees clockwise, it's going to be right in the middle here. Okay, so I can kind of see that the line goes through this point right here, pretty much. So yes, if I were to do this formally, I would be doing a perpendicular bisector to get 90 degrees. So going a little bit more than halfway. Actually, let me get right there. A little bit more than halfway down here. Then also do it from the other endpoint. A little bit more than halfway. And I can see that my prediction was correct. So, with some of these, it's fair game to sort of make a prediction where you think 90 degrees is going to be, because it's more than likely going to hit, an actual coordinate. It would be pretty cruel of me to make the point be 3.1 comma negative 2.2, right? It's going to usually be a whole number. So C prime is going to end up at 5, negative 2. And I'm just going to write that coordinate down just so I have it in case I forget. All right, now I don't really want this line here because I think it's sort of distracting. So I'm going to erase it. I'm going to put a C prime there. All right, so one thing I can kind of save myself some time here. If I know I'm rotating this shape, right, and A is going to stay where it is, C prime is going right here, well, B is just 2 units away from A. So I'm going to predict right here that's where B prime is going to be. I'm going to write that over here. B prime is going to be at 4, 0. All right, and D is just really 2 units away from A. If I rotate it, I can even rotate the paper itself 90 degrees. And I can see when it's rotated, D is going to be right below, 2 units right below A. So I'm going to put D prime right here. All right. And when I connect my dots, I can see that I have the exact same shape I started off with. And I know rotations are a rigid motion, so that looks pretty good to me. It's really like that point staying the same, and I'm rotating it, so that looks good. And I can check it with a compass if I wanted to. Like if I wanted to check B, I could, you know, put my center on A, pencil on B, do that rotation, and I go through that point where I put B. So that looks like 90 degrees to me, right? That's a right angle, so that's 90-degree rotation. All right, great. So let me make sure I write down D prime as well. That's at 2, -2. All right. So now I have to use this translation to get to my final, because we're doing multiple transformations. So I'm going to write out all my coordinates. So A prime actually stayed the same, so that was at 2, 0. All right, now I'm going to write A double prime. I'll do it in the same order. C double prime, B double prime, and D double prime. All right, so if I'm doing that transformation, I'm adding 1 to every single one of my x-coordinates. So I'm going to try and get that done all in one shot. 2 + 1 is 3, 5 + 1 is 6, 4 + 1 is 5, 2 + 1 is 3. Do the same thing, subtract 4. 0 - 4 is -4, -2 - 4 is -6, 0 - 4 is -4, -2 - 4 is -3. -6, I don't know where that came from. All right, so now I'm going to plot them. All right, so 3, -4, that'll be A double prime. All right, and really, once I've done A, I'm just going to make the exact same shape I made before, because like I said, it's a rigid motion, and a translation just sort of picks up a shape and drops it off somewhere else. So, you know, I could check it, but it's, you know, it's pretty obvious where it's going to be. All right, so D prime 3, -6. So yeah, that's exactly where I thought D double prime would be. C, 6, -6. All right, that's where I predicted it as well. And then D, or I'm sorry, what point would this be? This would be B prime, so E double prime, 5, -4. All right. All right, and they said label that result R. Great. Okay. That was more work. I mean, that was a decent amount of work because I had to do a rotation that was not centered at the origin. I don't have a simple rule for that. Hopefully this next one will be a little bit easier, and it looks like it is. All right, so first thing I'm going to do, I'm going to write my coordinates out. So I'm going to write A, B, C, and D. Let me move this up a little bit. Because really, I don't actually need to use this grid at all, because these are rules that we should have memorized, or we did at one point. So this will be good review to see if you remember those rules or not. And if not, you know, you can always look them up. You are in a pretty unique situation for this test where you will have all your resources available to you. So, I mean, memorization is not going to really be required. You could, you know, just have your notes with you. So you can thank coronavirus for that, I suppose. All right, A is 2, 0. B is 2, 2. C is 4, 3. And D is 4, 0. All right, so I'm going to write out A prime, B prime, C prime, D prime, and then A double prime, B double prime, D double prime. All right, so hopefully this will help so I don't have a super cluttered graph with like all these different transformations on it, and it's hard to find my final answer. All right, so the first thing we're doing is reflecting across the y-axis. So if you remember, our reflection over the y-axis, I always prefer to write as a reflection over x = 0. And the reason I prefer to write it that way is because when you reflect over the line x = 0, you just negate the x value. So this is pretty easy. 2 to -2, y stays the same. 2 to -2, y stays the same. 4 to -4, y stays the same. 4 to -4, 0 stays the same. All right. Then we're doing a counterclockwise rotation, which is the normal way we rotate, by 90 degrees. So if you remember, that takes a coordinate xy and brings it to -y, x. So first thing I'm going to do is just switch my coordinates. So I'm not going to worry about the negative sign to begin with. So I'm going to switch them. So they switch places. I didn't switch that one at all. All right, 3, -4, 0, -4. So the first thing I've done, I've just switched x and y. Now I'm going to go through my first column and negate everything. So the first thing I see is a 0. I can't negate a 0, so that stays the same. 2 becomes -2. 3 becomes -3. 0 has no sign, so again, that stays the same. And remember, if I had a negative number in this column and I negated it, it would become positive. Negate does not mean make negative, it means to change the sign or multiply by -1. All right, so that's all for 1.2. Oh, actually, wait, that's not all. We have to graph it. Label the result L. So I'm going to plot my points. 0, -2. That's A double prime. -2, -2. We got B double prime. C double prime is -3, -4. I shouldn't have labeled B right there. And D is 0, -4. All right, so I'm going to label that with an L. All right, I actually forgot to make a prediction, so I'm going to make that real quick. So if I had taken H and reflected it over the y-axis, it would have flipped over and landed like right about here. All right, and then if I'm rotating it 90 degrees, that's counterclockwise, that's going to rotate it down to this quadrant. So yeah, it does make sense that it would end up in quadrant 3. All right.